Hey coders, how you doing? So today we are going to discuss another question on the topic of try, that is nothing but replace what. So without wasting time, let's try to understand the question. So just to understand the question, I need some input. Let me take it from here. Okay, so here, uh, let me increase its font size. Okay, now I think it is visible to you. So before moving on to the before moving on to these thing that I have taken from the screen or from the portal, let me tell you something. Okay, so what means how the input is given to this question. Okay, so at first thing, if I talk about at first, there is an input, integer input is provided to you, that is a number. Okay, and for that number of times there are some words are provided to you which is actually stored in some of the array list or a vector or any of the data structure, or I can say the array of a string. Okay, it is stored in some of the array of strings. So it will be shown here something like this, that is a cat, bat, rat, and it is stored in the array of string. Okay, and after this array of string, one more uh, line or one more sentence, or I can say line, is provided to you, that is this sentence. And here you can see the cattle was rated by the battery. This is other sentence which is provided to you as an input. Now let's discuss what you need to do on this question to solve this question, actually what you need to do with this input. Okay, so what what is actually happened in this question is that you need to check for each word. You need to check for each word in the provided sentence that whether that word prefix is actually exist in a dictionary array or not. Okay, so there may possibility you're not getting my point. So let's try to let's try to understand it and break it into a simple words. Okay, so we already know that we are provided with two things. One is the array of string. This is the first thing, and the second thing with which we are provided is nothing but a line. That is a line, or we can say a sentence. Okay, we know sentence is nothing but a collection of multiple words. Okay, and what we need to do in this question is that we need to check that whether each and every word of that sentence, sentence prefix actually exists in this prefix array or not. Means here, let's try to understand here the sentence that we are provided is this: the cattle was rattled by the battery. So what we will do, we need to check for each word. That is, at first we'll check for the whether the that is the word prefix actually exists in this dictionary array or not. And here you can see that its prefix actually doesn't exist. So whenever you come to know that any word prefix actually doesn't exist in the in the dictionary array, what you need to do is that you need to add that word as it is in our answer answer string or the answer sentence. Okay, so as this the word prefix doesn't exist in the dictionary array, what you need to do, you just need to add it as it is. Moving forward, the second word is the cattle. So again, you will check that whether cattle prefix actually exists in the array or not. And here you come to know that yes, cattle prefix actually exists in the array. That is nothing but this cat. So the moment you come to know that any of the word have a prefix which actually exists in the prefix array, what you need to do, you just need to replace that word in our answer array with that prefix. So this word, that is this cattle word, get replaced by the cat here in the answer. Moving forward, so we have already worked on the and cattle. Moving forward, the next word is the was. Similarly, here also you will check for the was, that whether the was whether the was prefix actually exists in the prefix array, or we can say the dictionary of the string. Okay, and here you come to know that already also was prefix actually doesn't exist. So here also you just add it as it is, just because its prefix doesn't exist in the prefix array. Now again, you search for the rattled. Okay, you search for this rattled, and again the rattled prefix actually exists. That is nothing but rat. That is the rat. So you add its prefix into our answer array. Now for the by and the, for these two words, that is this by and this the, there is no prefix. So what we'll do, as per our requirement, we just add it as it is in our answer. The last word, that is the battery, we also check for it. Okay, and after the checking, we just come to know that yes, its prefix exists. That is nothing but the bat. and we replace we just add its prefix into our final answer. So here you can see that what we have done, we just check for each word that whether that word prefix actually exists in our answer, in our provided array or not. And if that prefix actually exists, what we do, we just replace that word, or we just add that prefix into our, we just add this prefix into our final answer. Okay, and if that prefix doesn't exist in the prefix array, what we do, we just need to add it a word as a whole. Okay, so that's why we have added this the, was, by, and the as it is. So that's all for the question part. Yeah, one more thing, one more case that is you need to tackle is, let's try to understand it. Okay, there is one more case which you need to tackle out. What if I say that there is one more prefix into this array, that is nothing but this CATT. Okay, now you might be thinking that this CAT and CATT is nothing but a prefix of the cattle. Okay, that is this cattle word. These both of these words are nothing but a prefix of this cattle word. Now what happened that when you try to find out the prefix, you encounter both of this word. Now you might be thinking that which word is suitable for putting into the final answer array. So in that case, means in any, whenever you encounter such a case in which you have multiple prefix for a for a single word, then what you need to do in such cases that you just need to attach the smallest one prefix. Okay, so that means our final answer in this case will be nothing but the CAT, that this prefix. So we have added this prefix. The cat was rat, that is this prefix, the rat by the bat. Okay, that is this prefix. So what we need to do is that whenever for any of the word there is multiple prefix into our string, what we need to do, we just need to take the take the prefix with the minimum number of alphabets, or I can say that we need to take the smallest prefix and just need to add that word, add that prefix into our final answer. So I hope you get the problem statement till now, and it's my request that you pause this video right now and try to solve it by yourself. And obviously after that you can easily watch, you will definitely watch the solution part. Okay, so I'm assuming that you have at least given a try of this question, and now let's discuss the solution approach. Okay, so here you can see that what was the question. The question was finding whether for that particular word is there any such prefix exists into the dictionary, or I can say dictionary array or not. Okay, so as we are finding something into an array, so there might be possibility you can think about the uh, what we can say the nested loop approach. That is, just take this word and search whether this word prefix actually exists in this dictionary array or not. And the moment you come to know that that word doesn't exist, just add the taken word as it is into our answer, and if a word exists, then add that prefix. So if you are thinking about such approach, then I can say that this is definitely not an optimized approach. Why? Just because for this the word, you are iterating the dictionary array, a whole dictionary array, just for the searching of this the word, and at last you just come to know that this the doesn't exist into the dictionary array. Okay, and the moment you come to know this the doesn't exist, you will add this word as it is. Similarly, you will do the same kind of work for the cattle. That is, you just took this word and the whole dictionary array search in the whole dictionary array for this for the prefix of this cattle word, and if you find that word, you will add it into our final answer. And if you don't find it, you just need to add the word as it is. So what is the what is bad in this approaches, for each and every word, like you are taking this the cattle was, for each and every word you just need to iterate over the whole dictionary array. That means if I'm assuming this the means if this has n elements and this has m element, then you are actually performing m into n operations each time. Okay, so this is not an optimized approach. Now you might be thinking that our find operation is costly. Here you can see our find operation is costly, and now you might be thinking that what if I put all the values of the dictionary array into some other data structures, that is either the hash map, hash set, or the unordered map of the C++. Okay, so you might be thinking to why not use such thing, because if I use such thing, then my find operation will become of the order of 1. Means in that case what we do, we there is some data structure, like I am assuming you are using any of the data structure, either a hash map or a hash set, and you have already put the data, that is this prefix values, into that data structure. And now what you are doing is you are each time extracting a word from the sentence and searching that word into the and searching that word yeah, searching that word into this data structures, hash map, hash set, unordered map, or the other data structures. You are searching that word, and we already know that the search operation this time is of order of 1. But what if I say that this approach, that using of the other data structure, is also not that good? No, apart from using of this extra space, this approach is also not good. Why? Let's try to figure it out. Because when you start searching for the 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 prefix of this the word, you need to check for each and every alphabet. Means each time you need to extract out a substring, and you need to check that whether that substring actually exists as a prefix into the prefix array or not. Let's try to understand why. Because here you can see that this prefix is nothing but cat. But what if this cat was not present, but cap was present into the dictionary array? If you just took this first word, that is the C word, as a pointer or as a delimiter to check that whether the prefix exists or not, then there may possibility you replace this cattle word by this cap word. So what you need to do, and definitely this cap is not a prefix of this cattle, okay, and this cat is actually not present, like I have assumed it, okay, I'm replacing this cat with a cap, and I'm assuming cat was not present but cap is present in the dictionary. And if you're taking only the first alphabet of each and every word as a delimiter to check whether that word actually exists in a whether that word's prefix actually exists in a prefix array or not, then definitely you can get, there may be possibility you can get the wrong answer, okay, wrong answer. So you can't use it. Means you need to extract a word each time, that is you have extract the word cattle, and for each time you need to check for each and every alphabet, that is you need to extract string from that word. At first you extract C, you need to check for C whether any of the prefix starting from the C exists or not, okay. Now if you come to know that yes, there is some prefix which exists starting from the C, now you need to check for CA, that is whether that Oh, okay. So whether that prefix which you have searched till now, whether that prefix starts with CA or not. Okay. After the CA, you need to check for CAT, whether that prefix start with a CAT or not. And you need to do it unless and until there is even a single word into this cattle, into this word, or unless and until that prefix will not become equal to this string. That is, the prefix was the cat, okay, and you need to perform this extract and the comparison operation till this cat will become till the moment you don't come to know this cat is actually a prefix of this cattle word, okay. So I can say that in the previous approach, the abstract view was take each word and check whether that word actually present in our whether that word's prefix actually present in the dictionary array or not. But if we go deep, it was not a good approach. But now after that, we come with a different solution, okay. We come up with a different approach of using the any other data structure, that is the hash set, hash map. But here also that approach was also not that good. Why that was not good? Just because when we go deep, we come to know that just to find out the prefix, we need to check for each and every alphabet of every word, okay. So that was not good, okay. So let's discuss the optimized approach. That is the best approach, or I can say the best solution to solve this question is using the try. Like we already know, we are discussing the try question, so definitely this question can be easily solved by the try. But how the try is actually used in this question, let's try to figure it out. So what I'll do at first is I will create a try of this dictionary data, okay. Means I will create this create a tree for each and every word. At first I'll create this with C, then this A, then this T. After that I create a tree with this B, then A, then this T, and similarly this R, this A, this T. I'm assuming one more, that is nothing but CA double T. Soon I will tell you that why I am assuming this one more prefix, okay. Just hold for a second, hold for some time, okay? As I will tell you soon. But here you can see that for this try word, try prefix, that is the cat, the t is a last word, okay? That is the finishing word. Similarly, this t here in the bat is a final word, and similarly this t in the rat word, that is the end word. And c in the cat, this is the last word. Now what you will do in the approach of try, here also you will extract each and every word, okay? You will need to check the prefix of each and every word. So what you will do, at first you extract the t, okay? The moment you extract the t, you check that whether the t's first alphabet, that is the t, actually is there any word present in the try starting from the t or not. So means here you are comparing this t alphabet with the with with the alphabet of a try, that whether any word of a prefix starting from t or not. And here you come to know that there is no word starting from the t, because now here you can see that this word is starting from c, this word is starting from b, and this word is starting from r. Means there is no word starting from starting from t. Now the moment you compare for each and every prefix word of a try for this alphabet, you can take a decision that that the prefix of this word, that is the word, doesn't exist. Now you don't need to compare for the other comparisons, so you just add it as it is into my final answer. Now again you extract the second word, that is nothing but the cattle. Now again you took the first character of that cattle, that is the c. Now you compare, or you check that whether is there any prefix exists in our try starting from the c or not. Or when you do it, you just come to know that yes, there is a word, or there is a prefix word that start from the c, that is this one. So you compare this cattle you compare for the c into a prefix try, so I can say it at try, okay? The moment you come to know that this c actually there is a prefix word that actually exists for this c, now what you will do, again you will not check for the ca, this time you will check only for the a, okay? So we'll check for this a, that whether that word you have found till now, whether that word actually consists the a or not. So here you can see that a actually present. So you move forward and you will check for the next alphabet, that is nothing but a t. So here also you can compare that whether that word actually consists the t or not. And here you come to know that yes, this word have the t, okay? This word has the t. And the moment you come to know, you encounter this ending alphabet, you come to know that the word you are, that the alphabet you are checking right now is the ending alphabet. You just come to know that I have completed, means I have completely iterated over the prefix word, or I can say that this word, this try word, is nothing but actually a prefix of that word I'm looking for. So what you'll do, you just come out, you stop the searching for the words, for the alphabets, actually you stop the searching for the alphabets, and you can see that yes, this cat, that is the cat, is nothing but an prefix of this cattle word. So you replace this cat with a cattle in our final answer. So I hope you get the intuition of this approach. What we are doing, we are just extracting out each and every word per, means each word, particular word each time, and we are comparing each and every alphabet of that word with the prefix words, okay? Means the tribe which we have created, we are just comparing each and every alphabet with that tribe word. And the moment we come to know that there is a word of that alphabet in the try, we compare its next alphabet, and we do it unless and until we don't encounter the ending position, or we don't encounter the mismatch between both of these words. So let's try to do it for the was. The moment we extract the was and we compare this w into the try, we just come to know that the try word starting with this w doesn't exist. So what we'll do, we just add this was as it is, okay? Moving forward, we extract out the rattled and we compare, we check, okay, not the compare, we actually check that whether any prefix word starting from the r actually exists or not, and here we come to know that yes, prefix words starting from the r actually exist in our try. So we move forward. Now we are comparing or looking for the a, and here we again compare in the same prefix, and we come to know that yes, a actually exists. We again move forward, we check for the t, and the moment we reach here, that is this t, we reach here for this t. Now what what we'll do, and here we come to know that yes, both the alphabets are same. The moment we reach here, we just come to know that this T is nothing but an ending position of this prefix word. So I can say that this word, this prefix is, this word we are comparing right now is nothing but actually a prefix word. So I'll add this prefix into my answer and I'll replace this rattled. Similarly for the by and the, there is no such word that actually exists in my try of prefix. But for the battery, there is a prefix which is actually existing, that is this B, A, and T. That is this B, A, and T. Now, I hope that you got the intuition that how we are using this try and how this try approach is actually better than the previous approaches. Here, we are just doing nothing. We are just using a little bit of the previous concept, that is we are extracting each and every word each time, but we are not looking for the substrings each time. Means we are not looking for C, we are not looking for CA, we are not looking for CAT. Each time we are looking for a prefix into our try. Okay, we are looking for a prefix. We are just comparing each and every alphabet each time, and the moment we come to know that such type of word actually exists in our try, then we move forward and start comparing each and every alphabet. Means at first we compare that whether the first alphabet of that word actually exists in our prefix or not, and if we come to know that yes, that word actually exists, we start comparing for the rest of the alphabet. And that's all for this approach. Now what we'll do, we'll move on to the portal and then we try to write code on that portal. So this is the pepcoding portal and now we are going to write the code. Okay, so we need to complete this replace word function and it have two parameters. It is the dictionary of a string, or we can say a vector of a string contains all my prefixes, and the second is the sentence, that is the whole sentence which contains words and whose prefix we need to replace with. Okay, so at first what I'll do, I will create a class while why just to create my try. For that I'm creating a class of name try and public, and there I will create two parameters, two member, what we say, the member function, data members of this class, that is the next, and its size, this next array, and its size will be 26. Why the size will be 26? Just because we know in the English language there are 26 alphabets, unique alphabets, and here in this question it is already been told that all the alphabets are in a lowercase, so I can confidently try my array of the 26 size. Similarly, I will create one more variable, that is the bool is word as false. Why I have created this variable? This variable actually does, it actually what this variable actually does, actually this, like the moment when I start creating the try, at each alphabet we need to store the value that whether that alphabet is the ending position of that is actually the ending position of that prefix or not, and if it is an ending position I need to stop at that particular point. So I need to store that information, and that information actually gets stored by this is word keyword. So now what I'll do, one more thing I need to do is creating a try. So at first I just need to complete that method. Okay, so here I'm completing it, void insert, I'm naming it as insert method, and here within this method I will create my try. So try star node and string word. Okay, so now try star itr, try star iterator as node, and let's move forward. For auto, let's try to iterate over each and every alphabet of that word, of that word. Okay, so for ch word, word word, and we check that whether if that at particular position, if at that alphabet there is no such node is already been created, if at that position there is no such node is created, then we need to create a new node. Okay, we need to create a new node. So let me create it. At first let me check it, if it at next ch minus at a, if at this position iterators next, actually iterators next ch minus a, If it is null, I just need to create new try. Okay, otherwise, okay, so otherwise what I need to do, I need to move forward. Iterator itr next ch minus a. Okay, otherwise I need to move forward out. And for each word, I just need to store some information. That is nothing but iterator is word equals to true. What this true signifies, this true signifies that this is not actually the ending position. Okay, and the ending, okay, sorry, this true signifies that yes, this is the ending position, and if it is false, it signifies that no, there are more alphabets actually lies within this prefix word. So let's complete the code of this replace word function. So now first what I'll do, I just create the object of try try star root equals to new try. Okay, and at first I just need to create the try for each and every word. So what I'll do, I'll call this insert method for each and every word. For that, for auto word dictio for auto word dictionary insert, I'm just passing the root and word within that, passing the root and word. Now I'm assuming that till now my try is actually completed successfully. Now what I'll do, I just need to create the answer. For that, I'm creating string result and int n equals to sentence dot length. I'm getting the length of that sentence. Now I am iterating over the provided sentence. So for int I equals to 0, I is less than n and I plus plus. Now here I'll write some code, and for that code I need, let me at first explain you that what I'm going to do right now. Okay, so I'm assuming that my let me take the string, the kettle was rattled by the battery. Okay, the kettle was rattled by the battery, so that was our string by the battery. So it was our string, or I can say the sentence. Now what I'm going to do, I'm just going to take each and every alphabet of that string one by one. Okay, I'm just going to take this T at first, then H, then E, and after taking each alphabet, the first alphabet of each word, I'll check that whether for that alphabet actually exists in my try prefix or not. If there is no such prefix, now what I'll do, I just keep on extracting that word, but I will not check in my try. But the moment I come to know that yes, that alphabet actually exists, now I just check for the other other alphabets also. Okay, and at last, if I come to know that yes, it is a prefix, the yes, that prefix exists for that word, I will just find this prefix and add that prefix in my final answer. So I hope you get it what I'm going to do now. So for that, I'm iterating over my provided string. So at first, let me create the int count equals to 0 and int length equals to 0. Int count equals to int count equals to 0, int length equals to 0. Again, let me create one more iterator just to iterate over the try. Iterator itr equals to, and initialize it with the root. Now the string word. What this word consists, the word extracted out from the sentence. Okay, moving forward, let iterate over the whole word. Okay, we will keep on iterating over the word unless and until we don't encounter the blank space. Okay, while I is less than n, we keep on moving on, and is alpha, alpha. We keep on iterating while I is less than n, and we keep on getting the alphanumeric in our sentence. So what we'll do at first, just add that sentence, or just add that alphabet character into a word as SCNTENC, sentence I into a word. Moving forward, update the length, and now again check in the iterator of the try that whether for that particular alphabet there is a prefix or not, it lies in the prefix or not. If itr next and next sentence I minus a. If such a case, then I'll update itr equals to itr equals to itr next sentence 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 I minus a. Okay, and update the count plus plus. Otherwise, what I'll do, I will also check if count is equals to the length and itr is word. If that word, that alphabet I am accessing, if that alphabet I am accessing is the final alphabet of that prefix, means I have completely iterated over the prefix, and if that is a prefix, that word is a prefix, then what I need to do, I just need to get that whole prefix and need to add into my final answer. Okay, so if such a condition arises, what I'll do, I will again write a loop, I is less than and is alpha cntenc sentence at I plus plus, otherwise I'll just break, and this come out of this loop. Okay, now I just need to update I each time, and at last, while coming out of the loop, I just need to add that word into my final answer with a space between them. And at last, what I need to do, I just need to return something. Return result dot as substring 0 to result dot length minus 1. Why I am here extracting out the substring? Just because at the end there is one more blank space which I don't require, so I just need to remove that, and for that for just to remove that, I am extracting out the result length minus 1. I'm extracting the substring of length minus 1. So I hope I have completed the code. Yeah, that's all the code. Now we are going to run it, and if we encounter the errors, we try to resolve it. So yeah, we get the first. Okay, we just forget to close this class. Okay, now okay, yeah, our code is accepted. So that's all for this video. I hope you get the intuition of this question. I hope you get the concept of this question. Now it's my request, you please go and try this question by yourself, and let's meet in the next video. If you like the content of this video, please hit the like button, try to share this video with your friends, and please subscribe our YouTube channel. So till then, stay safe, stay healthy. Let's meet in the next video.